Okay, in the meantime, a couple of other things that happened that
Yeah.
I should probably fill in.
Yeah.
That is to say, I had a girlfriend. I had met her at Goshen College. We both worked on the newspaper together. And she was a nurse, and it happened that she got the offer to come up to Boston with another nurse friend to practice. And so there she was in the vicinity. So we began to see each other quite a bit, and I told her, I know where I'm going to spend my honeymoon. There is this eclipse coming up, and if you're interested in seeing a total eclipse of the sun, you should get more interested. And so that's how it worked out.
This was a marriage proposal, was it?
This was a marriage proposal. And we've been married now over 50 years.
I've met your wife. Remind me of your wife's name.
My wife is Miriam.
Miriam, that's right.
And, well, I guess I have to say that it turned out to be cloudy on our honeymoon. But in the meantime, I think I've taken her to 10 total solar eclipses that she has seen. So I'm typically the lecturer on a cruise ship. And I say, okay, everybody who's stand up now. Those of you who have never seen an eclipse can sit down. Now, if you've seen 2 eclipses or more, you can stand up. But if you've only seen 1, sit down. And gradually you work down, and well, very typically Miriam is the only one left standing. So that was one thing. And the other was that in my graduate work, thinking I was going to be drafted at any moment did not seem too propitious to get deeply involved in a thesis, only to have to abandon it. So I did, however, get a job as a teaching fellow in a general education course taught by Professor I. Bernard Cohen, who was essentially the founder of the History of Science department at Harvard, and who was a very gifted lecturer and ran a big course for science students, but using the historical approach. And I think Bernard Cohen, despite the fact that there was an intense love-hate relation between us, because I felt he was a little bit pompous and often rather unreasonably demanding without thinking to say thank you. But nevertheless, I learned a great deal about lecturing technique, about how to pace things, sort of what level one should present the material at for the non-science students, how you would go about grading in an equitable way. All of these things were very helpful. There were a group of us who were teaching the sections, and that not only got me really interested in teaching, but also fascinated by the history of science. So I gradually began to do more and more reading in the history of science. I've never had a history of science course, but I am an autodidact in this respect. Well, I got this offer to go to Beirut, to the American University, to fulfill my obligation to the American Selective Service System. So off my new wife and I went to Beirut, and it was a very interesting 3 years. 2 years required by Selective Service, but I stayed a 3rd year because I had things that I was still wanting to get fixed up in their observatory before I left. And also I said, I'll stay if I can teach the junior mechanics course. And so teaching beginning physics to rather obstreperous young Arab students was a great experience for me, because I was always intimidated about whether how I would do in my final oral exam. And in the end, I didn't really appreciate the fact that the oral exam is not to find out what you know, it's to find out what you don't know. And it took them a long time to embarrass me thoroughly. So I must have had one of the longer PhD exams of that period. In any event, I was not happy to have been drafted out of graduate school. But as Kepler said, he thought it was divine providence that Tycho Brahe had left Denmark in a huff, because he had an invitation from Tycho Brahe to go up and see Tycho's wonderful observations, but Kepler said Denmark was much too far away. But when Tycho came down to Prague, which was in range, and Kepler got a job there, he didn't say that he thought it was divine providence that Tycho promptly died and that he inherited all his data. But I suppose it was divine providence that I was drafted out of graduate school, because in the meantime, the Sputnik had gone up. The Smithsonian Astrophysical Observatory had moved to share quarters with Harvard Observatory. There was a tremendous burst of growth there, but they also had the fastest computer in New England with extra time on it. And as I said earlier, I was interested in spectroscopy, in spectra, but it was very hard to get the material to use. What happened was that I turned to the theoretical side. I got permission from Cecilia Payne-Kapashkin to switch my advisors. I went with a younger professor who had, in fact, entered graduate school with me, but with a better background and had graduated very quickly. And he was very interested in using the computer to calculate what we call model stellar atmospheres. That is to say, in detail, the way the radiation flows through the outer layers of a star. And previously, everybody had assumed that the stars were gray across the wavelength regions, so that you would not take into account the different opacity of the atmosphere in the different colors of light. But with a computer, you could handle the whole thing. And so this was, nobody had ever been able to do this before. And I just loved the computing. I ate that up. And so I was soon very deeply entrenched into this cutting edge area. The result of which was that I had a great thesis and a job offer from the Smithsonian Observatory to continue in this kind of work, because they were planning to send up a special satellite to look at the sky in the ultraviolet, and they needed theoretical capability to interpret what was going to be coming out. So I got very much involved in that. And I wasn't involved in that position very long when the astronomy teacher of their basic Nat Sci course, the Natural Sciences course in the general education program, got a job offer and left rather late in the season, and they needed a teacher for the following year. So they asked, would I be interested in doing this? Well, I had had the background with Bernard Cohen, and in fact, when I had returned from Beirut, Bernard Cohen had employed me to be a lecturer in his course. So I did part of the lecturing, and so I had this definite experience of teaching in Beirut, and then also teaching in the Harvard program. So I took over this course, and I gradually worked my way into it, molding it to my own ideas of how it should be run, more and more, introducing much of the historical material that Bernard Cohen had used earlier. This was the astronomy department's offering, not the one that I had originally been involved in. I kept on teaching this and developing it and taught it for a good long time, so that ultimately when I retired in the year 2000, it had become the longest running course at Harvard under the same management. I mean, the economics course was offered every year for a century, I suppose, but it was always having changing faculty. And during this time I had 100 teaching fellows working with me. I often said that teaching the teaching fellows was my most important job. I've had some of these teaching fellows going on to very distinguished positions, and in fact one of them won the Nobel Physics Prize.
Who was that?
David Politzer, who was, interestingly enough, doing his prize-winning graduate work at the same time he was teaching for me.
You mentioned there were 4 significant people. Your father was one. You sort of implied that...
Bernard Cohen was another,
yeah,
because of his giving me such a foundation for teaching.
Yes.
Well, Bernard Cohen got me involved in another operation. He had become a historical consultant for IBM, and he brought me in on that project, which involved working with the very distinguished designer Charles Eames. So I went out to California fairly regularly to look at the exhibits he was making, like a huge time wall of computer history. And then he did a special exhibition on Copernicus, in which I was sort of the key person, and so on. And Charles was probably the most creative person I've ever worked with, because he not only designed chairs, and to the degree that you find them in the collection of the Museum of Modern Art, and the U.S. has just put out a sheet of stamps showing, I think, a dozen different chair designs done by Charles Eames and his wife Ray. So
he was a great chair designer, but also many other kinds of creativity.
He did a film entitled The Powers of Ten, and I'm one of the people thanked at the end of that film, although most people who run the film don't bother to run it through the credit lines.
What would you put his creativity down to? I mean, very simply, curiosity, or...?
It was a kind of curiosity, and such a wide interest in all sorts of things. He made a film simply entitled Toy Trains, because he was a collector of toys, of historic toys and other ones, and so on. But I went on a photographic expedition with him to Poland and to Sweden in connection with the Copernicus exhibition. And I learned a great deal about photography, about seeing things in details, about taking the pictures of books at interesting angles, not just flat on, so that you got more of a sense of it as actually being a three-dimensional object and not just a flat page of text. So a lot of those things I've continued to use. He invented the multi-screen projection show. He did this first in a great way for the U.S. Pavilion at the International Fair in Moscow, and then brought this to a considerable art. As a result, I started showing my slides always double, two-screen at a time in my class. So he was just an incredible sort of person to work with. For example, he was flying back from Poland from one of the trips, and he realized that if he wanted to get to the nub of what Copernicus was doing, he wanted to show how the Ptolemaic geocentric system gave the same answers as the heliocentric system, but the vectors are arranged in a different way, but they point ultimately in the same direction. And he figured out how to make a model of this with bicycle chains hidden in the background. And within 2 or 3 days of his returning, he had figured out how to do this, and his shop had made this model, which was rugged enough to run for 6 months in the exhibition without breaking down. I often put it as a challenge to my students to figure out how this could be done, so that I could have a model like this too for showing to the class. And no students were ever ingenious enough to figure out how to do it. They could figure out how to do it on the computer, but not with bicycle chains. And the fourth person,
yes,
a very good friend who lived very close to us, that I first got acquainted with as a result of some of these educational things for the schools, now in the English use of schools, pre-college level. And that was Philip Morrison, who was an extraordinary polymath, who for many, many years was the book review editor for Scientific American. So his home was always filled to overflowing with the stacks of books that were coming in for review, only a small fraction of which ever got reviewed. And so he had this problem of how to get rid of books. So my wife and I would often go over and write our names in books, which in due time then we would come and collect. So,
and that was his main influence on you, was it? Or?
Talking about just so many different kinds of things. He went out and worked in the Eames shop for a year while he was on sabbatical. Or rather, his wife worked in the shop, and he would come in from time to time and consult with things. I think he was teaching at UCLA or something like that, maybe at Caltech during that year. But he was probably the most unforgettable character I've ever met. He worked at Los Alamos. He had lots of stories about Los Alamos. He came to our house one 4th of July, and our sons had mixed up some fireworks from basic chemicals and so on, and so we had a fireworks show in our backyard. And Phil said, well, I had some experience with fireworks, and of course he was there for the Trinity explosion at Los Alamos, but that wasn't the story he was about to tell. They had to make a test explosion to calibrate the instruments for the Trinity test. And so he said this officer was in charge of these enlisted men who were throwing the boxes of dynamite off the truck. And Phil was about to disappear. And the officer said, no, there's no danger in these. They don't explode in conditions like this. Here, I'll show you. And he instructed the enlisted men to stack up the boxes of dynamite in a wall and to bring somebody with a machine gun to machine gun them. Phil said, I didn't stay to wait for the demonstration. They did ultimately, of course, ignite them all to calibrate the instruments just prior to the test. Well, he had lots of stories like that, and he was the person who flew with the core of the bomb to Tinian to put it together before it was flown over Hiroshima.
Did he have any comments about the ethical?
Absolutely. He became one of the leading members of the...
Pugwash.
Well, yes, but of the movement to ban nuclear weapons. And he was one of the earliest people in to both Nagasaki and Hiroshima. We were once in a restaurant with another physicist sort of talking about this. It was a a Japanese restaurant, and the waitress came up and said, "Oh, I'm from Nagasaki." And she just overheard the word. It brought a deathly silence to our group.
I imagine. Let's return to Copernicus. We left the story that you didn't in fact mention the man who, the name of the man, was it Jan?
Jerzy Dubczycki.
Yep.
And he, over the years, got higher and higher in the Polish echelons, and finally became the director of the History of Science Institute in Warsaw. So I became very friendly with him as a regular collaborator, and he was often able ultimately to come to the States to work with me.
Yep.
But I saw when I was on this International Copernicus Committee with this anniversary coming up that probably I would be expected at some point in that year to say something about Copernicus. But what in the world could I possibly say that would be new? Copernicus had been studied for some centuries, and the archival materials had been well worked over. I went on a sabbatical leave in 1970 to Cambridge, England, and on a holiday we took the children up to Edinburgh. And on the way I stopped in Leeds with another professor who was also on the International Committee to plan these Copernican celebrations. And we talked about Arthur Koestler's book, The Sleepwalkers, which was a bit of a put-down for Copernicus, saying that it was the book that nobody read and an all-time worst seller. And, well, we started thinking about it. Probably there were more people alive at that time who had read Copernicus's book to the end than in all of the 16th century. And we started to try to name the people that would have been the readers. Rheticus, the young man who had persuaded Copernicus to publish, Kepler, Kepler's teacher Michael Mestlin, probably Christopher Clavius at the Collegio Romano in Rome, and so on. Tycho Brahe and Erasmus Reinhold, who was the chief astronomy professor in Wittenberg. We basically ran out of names, about 10 people we could figure out. So we turned to other topics, and 2 days later we were up in Edinburgh, and I went to the Royal Observatory to look at their fabulous book collection. And I took a look at their first edition of Copernicus, and I was amazed to realize that it was annotated thoroughly from beginning to end in the margins of the book. Now, if this book had so few readers, it seemed preposterous that the very next copy I happened to look at would be so thoroughly well read. So I scratched my head about this and wondered, you know, who in the world could possibly have done this? There was no name written in the book, but there was a special binding. In those days, 1543 was when the book came out, books were sold as stacks of paper, and each buyer would have it bound to suit his own taste and pocketbook. And I saw the initials were stamped into it, and I saw the initial ER, and I thought, my goodness, could it be Erasmus Reinhold? And I grabbed a sheet of paper to make a rubbing of it. And when I did it, to my dismay, a third initial turned up, ERS. I didn't know, because at that time I just wasn't deeply into these things, that it was typical in the 16th century to use a toponym, the place where you were born. And he was born in Saalfeld, and that stood for Erasmus Reinholdus Saalfeldensis. So it was exactly right. I had found one of the copies of those 10 people whose names we had suggested as possible readers. Well, this gave me an idea. I thought, maybe I should look at some more copies. It would be kind of interesting to see what people wrote in the book in the 16th century, and nobody's really done this. Maybe I'll have something to say during this celebration. So that's when the great Copernicus chase began. I went back to Cambridge. It was easy to figure out where the books were in Cambridge because there was a printed catalog of 16th century books in the college libraries.
There are about 9 copies, is that right? I think from your book
something of that order, but one of these copies wasn't in the this book because it belonged to Trinity College, which had 3 of them. And they thought that that was too many and they would sell one. But as the price of the book started going up, they realized that if they auctioned it at Sotheby's, it would be in the London Times, and people would think that Trinity was selling off its patrimony, that they had too much wealth already and they would lose out on other donors. So they changed their minds about whether they would sell it or not. Any rate, one thing led to another, and it became not just a simple research project, but it became an obsession to try to see as many as possible. And it took me 30 years before I was able, finally, to publish the census of some 600 copies of the first and second edition of this book, giving the provenances, the ownerships previous of each of the copies, to the extent that one could figure it out, plus information about what, if any, annotations were in it. And the annotations proved to be pretty interesting. The most interesting thing was this intense connectivity between copies. That if you got a book that seemed heavily annotated, you were almost certain to find another one with identical annotations in it, because students copied their teachers' notes. And for Erasmus Reinhold, there are at least a dozen copies which have some of his annotations recopied into them. But I can't give you more details than this. But after I did the census, I wrote a memoir about it. It's entitled The Book Nobody Read. And my publisher was very nervous about that title. After it came out, he said, "That's an inspired title. It's stopping all these book buyers for the big bookstores dead in their tracks."
It does, because they think, well, maybe I'm the first person to read this book. It's a very good book. I've just started reading it, so I'm really enjoying it. Detective story. What proportion, you said you saw about, or you listed about 600. What proportion?
I couldn't see all of those because I listed a few copies that had been destroyed in World War II. I am now in the position of having seen more copies than can be located, because a number of first editions have actually been stolen, and some have passed through the market to new owners unknown. So I have a considerable record. I've probably seen more copies of that book than the original printer, than anybody since the original printers.
Fascinating. Tell me, you've been very patient, but there were just a couple more questions I wanted to ask you. One was, I've interviewed 1 or 2 other astronomers, and I wondered whether you could comment on whether you've met them and whether you know them. One is Martin Rees.
I've known Martin for a long, long time. In fact, when I first went to Cambridge on that trip, he considered me a very senior person in comparison, because he was quite young then. I spent half the year in Cambridge and then went off to Beirut in the spring semester because I wanted to show our 2 oldest sons where they had been born. And when I came back, there was a conference at the Astronomical Institute, and I recently found the group photograph, and there is Martin sitting in the front row looking very young, and I'm standing just behind Jeff Burbage, looking very young, and near Martin Ryle, Fred Hoyle in the front row, with Margaret Burbage and Willie Fowler, and Roger Penrose is in that row, and so on. It's quite a distinguished galaxy of people, and I thought, my, what distinguished company I was standing in for that. So anyway, Martin and I have been talking about things for a long time. Every time I go over, I try to go and see him, and he's such a wonderfully patient person. You would think he had nothing else to do.
I know, that is an extraordinary feature of him. He's so incredibly busy, but he always seems to have time to, and interest. And but I mean, it may be an unfair or a difficult question. I mean, Cambridge, to me, has two great astronomers, Stephen Hawking and Martin. And when I've asked other astronomers to compare and contrast them, they've been very level-handed, and they've said their styles and approaches are very different. How would you characterize Stephen Hawking and Martin's contribution?
When I was first there on the sabbatical, there was a Thursday luncheon meeting of the astronomers, and Stephen Hawking came quite regularly. At that time, he still drove his own specially equipped car. So I didn't interact with him particularly frequently and so on, but I think he knew who I was because I was somebody who came to the meetings pretty regularly. I followed his work from afar, so he has done several quite brilliant things with respect to cosmology, with respect to black holes and so on. He was obviously not in a position to be the director of the Astronomical Institute, which Martin was. Martin has his finger in just sort of a lot more things. It's hard to compare them as to what their ultimate impact will be seen to be in terms of the pure science. In terms of working as a very effective administrator, of course, Martin Rees is going to make a considerable mark that way. So we enjoy getting together to gossip. We usually have a lot of gossiping to do.
Lovely. The other person who you mentioned, Ryle, but did you know, or do you know Anthony Hewish at all?
I know Anthony Hewish pretty well, all to the extent of always calling him Tony Hewish.
Yes.
And so there was, in fact, the time when I had gone over on the overnight flight to London and was walking around in a somewhat of a daze, and it was early in the morning. I was waiting for things to open up, and who should I meet in the Burlington Arcade but Tony Hewish. I said, "What are you doing here?" And he said, "Well, I'm going to give a Friday evening discourse at the Royal Institution." And I had heard about those, started by Michael Faraday, well over a century earlier. I said, "Oh, I'd love to come to one of those." And he said, "Well, I'll get you a ticket." So, in fact, I was able to go and hear him lecture, which was a splendid lecture. When I came on my next sabbatical, I told him, you know, I'd really love to give one of these lectures. And he said, "Oh, I'll put your name up." And in fact, I was invited to give one during my sabbatical year, which was a very interesting experience. But at any rate, I have known Tony for a long time, and for a substantial period of time we exchanged Christmas cards. And,
well, it'll be nice to add your interview to his. The last question is a very unfair question, really, but you seem to have had many careers, but in particular two, which is as a very distinguished astronomer and as a very distinguished historian of science. If you had to weigh which you would like to be most remembered for, what would you say? Which has been more important to you, shall we say?
I've always been interested in how science works. What are its claims to truth? How do these claims stack up vis-a-vis religious claims? And it seemed to me very important to do some science so I could understand and appreciate how you handle raw data, how you learn to trust or doubt it. Because when you're working on the cutting edge, things are not clear-cut. Otherwise, somebody would have already done it. But at a certain point, we got a new director at the Harvard Smithsonian Center for Astrophysics, and it was George Field, and he was interested in bringing in a new group of X-ray high-energy astronomers to build up a whole new section. And therefore, he was sort of wanting to cut down in some of the other areas. And I had a graduate student that I had hoped would be able to come back to a position there and continue to work with me on the stellar atmospheres. And George said, well, you know, if you'd rather just do history, I wouldn't have any objections to that. So I figured, well, if he wasn't going to get me some assistance, I would probably concentrate on the astronomical things. We had the 400th anniversary of Kepler in 1971, and I worked quite intensively on that. And about that same time, I was the lead author of the last astrophysics paper I wrote. Now recently we had a big Kepler symposium in Poland, near the place where Kepler spent the last years of his life. And I suppose about 3/4 of all the Keplerians were there. And they very nicely gave me an honorary degree. And in the citation they mentioned that one of my astrophysics papers, the last one I wrote with a group, had 720 citations. I had lost track at about 500, so I was pretty surprised at that. So it taught me an interesting lesson, namely that the number of citations is a very weak test of the significance of a paper.
That's a very nice point to end on. So we'll just stop there. So Owen, to continue, I asked you the question of whether you would like to be considered primarily as a historian of science or as an astronomer, or whether they were equal in your regard. So I think you thought a little more about that. What would you say now?
I suppose as a historian of science, but basically, as I said, I was interested in knowing how science works. And by doing science, you get some insights, but the history of science gives you a broader perspective, and sometimes it's easier to tease out the meanings of what happened 100, 200, 300, 400 years ago. So I've devoted a lot of time to thinking particularly about Renaissance astronomy and exactly what the relation between observations and theory and scientific proof versus scientific persuasion. And that gives me also a foundation for thinking about the broader questions of where truth lies in religion versus where truth lies in science and so on. So I suppose as a historian of science, my contribution would lie in the work particularly I've done in making the census of Copernicus's book. But I hope I've got further insights into how Kepler was thinking, how Galileo was mapping the moon, and so on. I've worked in 20th century astronomy as well as ancient astronomy. I'm not sure how well read those papers will be, but I hope they've made some contribution.
Coming back to the question of persuasion, you rather counterintuitively argued in the paper you've just presented that whereas I and many people thought that the great scientific breakthrough was the movement from persuasion, i.e. medieval pressures towards believing certain things, towards the Baconian idea of induction and proof. And you argued exactly the reverse, it seems. What exactly do you mean by arguing this reverse?
Well, there was a lot of argument. For example, what Cardinal Bellarmine told to Galileo suggested that he should look for a deductive kind of proof. To really be sure, to have an apodictic or irrefutable proof, you had to work with Aristotle's laws of deduction. Whereas the way we learn things is basically by induction, becoming familiar with many cases and generalizing in that way. And Galileo was essentially using inductive methods, and he was unable to get the kind of proof that Cardinal Bellarmine was looking for, or that Urban VIII suggested would be required for the Copernican system. In the end, Galileo's arguments proved very persuasive for the Copernican system. If you look in a textbook today, the arguments for the mobility of the Earth would be largely what we call the annual stellar parallax, the movement of stars, the reflex movement of stars because of the Earth's movement, or for the rotation of the Earth, the Foucault pendulum. Yet when those two things were finally discovered as proofs, it was too late in a sense because everybody was already convinced. There wasn't dancing in the streets in that morning in 1851, after which Foucault had swung his famous pendulum in the Panthéon in Paris. People were already persuaded by the coherence and the breadth of Newtonian physics. So in looking historically, I would say that a great deal of how science goes is by persuasion. If you look back 400 years ago to Kepler's great Astronomia Nova, you discover, if you look at the structure carefully, that a great deal of that book is to persuade his audience that he has tried hard enough to get an alternative to the elliptical orbit. And therefore, guys, you better just give up this ancient notion that astronomy has to be done with a uniform motion in circles. That's not good enough anymore.
Thank you. And just another couple of questions. One is the conference we've been to is about creativity and the conditions of creativity. Have you, in your studies of Copernicus and Galileo and Kepler, noticed any common themes which suggest why they were such creative scientists?
They were willing to think outside the box. They were willing to let their sense of the aesthetic overrule what seemed to be common sense. For Copernicus, the idea of being on a spinning Earth is ridiculous. And he was afraid of being hooted off the stage, as he said, by people who felt that this was impossible to have the Earth moving swiftly. But what Copernicus had seen was, once he made this transformation to place the sun rather than the Earth in the center of things, then you automatically had the planets arrayed in orbits around the sun, so that the planet closest to the sun, Mercury, went around the fastest, and the one farthest, Saturn, was the most lethargic, and the rest fell in between. And it was a beautiful unifying idea. Suddenly you had the same kind of pattern for each planet, which before was an individual mechanism. And I think it was the power of that aesthetic that won the day with Copernicus. And it took a while before there were other people who were willing to be swayed by that approach and that view, and that somehow that beautiful argument corresponded to physical reality.
Is there any evidence of how these people actually came to these discoveries, in the sense of the lay public often think of scientists as thinking and thinking about a problem, and then, as in the famous eureka moment, suddenly it clicks, they are on a walk, they wake up in the morning, something happens, and it's very, very sudden when the whole thing shakes into a new pattern. Is there any evidence that any of these three worked like that?
Well, I suppose you can trace it that way with Galileo, because Galileo wrote early on to Kepler that he was a Copernican, but secretly. Yet he didn't seem to teach it at all, made no publicity about it, and I suspect he had serious doubts about it until he found out about the telescope and was able to improve it so that he could change what was a carnival toy into a scientific instrument. And when he started looking at the moon and had enough of an artistic background to understand the shadows and the light in terms of topography, he realized that he was looking at an Earth-like object, and that wasn't how it was supposed to be in the Aristotelian cosmology, because the moon and the planets were something totally foreign to the Earth and the terrestrial elements. And I suspect there was some kind of eureka moment. It may not have been one evening, but perhaps a series of evenings in December of 1609. And out of that, he emerged as a convinced Copernican. It's a little harder to figure out when it happened with Kepler, but even as a student at the University of Tübingen, he engaged in a student disputation, arguing in favor of the Copernican system. And somehow that challenged him, and he asked a series of very strange questions, such as, why are there only 6 planets? And why are they spaced out with so much empty, apparently useless space in between, which they didn't have in the nested pattern that was used by the followers of Ptolemy? Well, when he got the idea that maybe the famous Platonic solids, the tetrahedron, the cube, the dodecahedron, and so on, could fit between the planets as spacers, and there were just 5 of these Platonic solids and 6 planets that had spaces then between each successive one. This was a wonderful insight for him, and of course, as he worked it out, he thought that this whole Copernican system represented the Holy Trinity. He was trained as a theologian. He saw the sun, the space between, and the distant stars as the same 3 components that you would get in the Trinity. So it was kind of crazy, but it was apparently part of that extended moment of eureka.
Lovely. I've asked questions which I often ask, and I haven't asked you about music. That's the only question I can think of that I haven't asked you about, really. People talk about the music of the stars, and many people find that their work is inspired or helped by music. Has music meant much to you?
Both my wife and I share very common interests in classical music, and we're great listeners. So we've often gone to concerts together. We have a substantial collection of classical CDs, but we're not performers. It's like a art teacher told me when I was in middle school. She looked at my work and she said, "Owen, you will be a great appreciator."
And if you could only take 2 or 3 composers with you, who would you take?
Well, I guess Beethoven and Mozart, and perhaps something more modern, perhaps Schubert.
Are there any questions which you would have liked me to ask you? Is there anything particular that I've left out?
I'm afraid this has been terribly comprehensive. It's a little hard to say. I mean, I have other strange interests. My wife and I have an international class shell collection, and we go after some esoteric aspects of shell collecting, I mean, from certain species. Our collection contains 2 world record size specimens in the Fusinus genus, and it's a specialty collection that we have, and so on. I'm interested in other things, the question of fakes and forgeries, and I've done a certain amount of detective work along those lines. But when I'm really having my nose to the grindstone, it's probably recomputing some 17th century astronomical table and figuring out how a relatively incompetent Dutch astronomer almost drove Kepler's great Rudolphine tables out of the market. Things like that I love to work on.
I've got just one more question, perhaps, which is maybe a little difficult for you to answer. During the conference that we've been to on creativity, a number of those involved, both British and American, have expressed anxiety about the way in which science is going in the States and in Britain. Things like increased bureaucratization, commercialization, use of citations indexes, and so on. How do you feel, looking back over your long time in science, do you feel that the conditions for younger scientists now are more difficult than when you started?
Well, not necessarily. I have had a wonderful group of teaching fellows, nearly 100 of them, who worked with me over the course of my teaching career, and many of them have turned out to be very gifted astronomers and are in secure positions and doing wonderful work. Some of them went off into medicine, some of them went to teaching positions in smaller places, but I think they are doing very satisfying work. One of my teaching fellows, for example, has become a professor at a Christian college in the American Midwest, and with his students has got them into the process of discovering asteroids, and they have discovered maybe a dozen or more asteroids. And he went as a research project after the asteroid that's named after me, and found that it is spinning at one of the fastest known rates for an asteroid, or possibly it's a very close binary asteroid, something that tickles me quite a bit.
Is it called the Gingerich asteroid? Or
yes, that's right.
How nice to have one named after you. And maybe a shell as well one day. Anyway, I think probably that's a very useful supplement. So thank you again for both the interviews.
Well, I've enjoyed talking with you, and hope that maybe my grandchildren will cherish copies of this